So let's solve question 2 of the applications assignment. It's another word problem. So the roof of a building. So I'm picturing a roof. It slopes at an angle of 32 degrees. Now they only give me one slope. So I have to imagine that my roof only has one slope. It's not one of those roofs that has two slopes and a peak. So it's 32 degrees, so here's my angle from the horizontal. The horizontal distance, or the run of the roof, is 6 meters. So, because I'm assuming only one slope, this 6 meters, this is going to be the horizontal side of my triangle. This is the full run of my right triangle that I'm going to use to conceptualize what this roof looks like. Compute the rafter length. Okay, what's the rafter length? This is a piece of construction terminology. This is construction jargon. The rafter is the side of the roof that slopes. So this is going to be like the hypotenuse. This is going to be the longest side of the roof. I'm also asked to round with consideration of accuracy. So these are a bunch of words. I'm a picture sort of person, so let's sketch this up in AutoCAD to see what it looks like. Alright, so I'm going to use a polyline, and my horizontal distance is going to be 6. And I don't know what my vertical distance is, so I'll just do a random vertical distance upwards, and then I'll go and start a new line from the original vertex, not with ortho mode on, but I will have polar on, and I'll set my increments at, was it 30 degrees? Or do I have to use a polar coordinate for this one? Let's see. I'll go back. Okay, 32 degrees. So I'm going to have to use a polar coordinate for this one. So I'll do at, my length was 6, so let's do 10 just to be safe. Alligator symbol, 32. And there is that. I can use trim to trim away the edges. Alright, excellent. So, just to confirm that this is 32, I'll turn off grid snap so that I can actually select the edge. Yep, there we go. And this is 6. Alright, here's where I'll turn the grid off. Here's where I'll go to my notebook, clip a picture of this so that I can start solving it. Yeah, I didn't want you all to see that. That's from the last problem up above there. Alright, let's solve this triangle. So I'm given a side and an angle. Now don't forget, I also know another angle. I know the right angle. I know that this is my right angle. So this is going to be, I have two angles on one side. It's going to be angle, side, angle problem. Hope that's okay with you. Our question 1, that was a side, angle, side problem, because we had at least 2 sides, and they actually gave us the hypotenuse on that first one too. So it was really straightforward from there. But here, it's a little more difficult. We actually have to acknowledge which methodology we need to use, the side angle side or the angle side angle. So here's going to be angle side angle, and our methodology for angle side angle is to first find the other angle. So let's first find out what that other angle is. What is that other angle? What is it? Well, it's 90 degrees minus the angle that we have, which is 32. This is going to be equal to, so 58 degrees. Alright, that's one. That's one question answered. Or that's one unknown solved for, and I'll actually just write that up. I'll actually just write that up here, 58 degrees. There we go. And now we need to solve for the sides. So specifically, I need this rafter length right here. So if I need this rafter length, and let's call it small a. Why not? Let me do that in a different color. Let's call this small a. So if I need the rafter length, I need to find a trig function and ratio that includes that unknown that I want, that includes this unknown that I want, and one of my known angles. So let's try and figure that out. I'm going to write them out first. So sine, let's do sine of 32, because that was our given angle. Let's start with sine. So that's going to be the opposite. Let's call this other side B. Sorry, I'll do that in the same color that I did the last one. There we go, B. So sine of 32 is equal to the opposite side, which is going to be B, over the rafter length, A. Here we have two unknowns, so that's not really going to work out for us. Let's try cosine of 32 degrees. So here we have the adjacent, that's going to be 6 over our rafter length of A. Hey, this is going to work out for us. We found one that works. Let's just hit it and run with this one, huh? And you can guess that tangent is not going to even have the rafter length in it. Actually, I'll write that just so that's clear. Tangent is opposite over adjacent. Opposite over adjacent. This doesn't even have the rafter length in it, so our lucky trig function is cosine. We'll use the cosine. Okay? We will not use this. Boo tangent, boo sine. We're not going to use those. Okay? Alright, so cosine. Cosine is 6 over A. How can we solve for this? Well, first we can multiply both sides by A. So A times cosine 32 equals 6 over A times A. The A's cancel out. So we're left with A times cosine of 32 equals 6. To get A by itself, we can divide both sides by cosine of 32. So divide both sides by cosine 32. Remember, we're not changing the equation at all if we do the same thing to both sides of the equation. We're not changing anything. So the cosines of 32 cancel out. And what we're left with is A equals 6 over cosine of 32. Let's go to our calculator to solve this out. So first let's figure out what the cosine of 32 is. Cosine 32 equals that number. And then let's do 6 divided by that number. That equals 7.07. Now we just got to round it to significant digits. If we remember from our original problem, in our given information, 6 was the least accurate number. It has one significant digit, so our answer should have only one significant digit. Let me pull that up. So this would be 7, just straight up 7. So let me write that out. This equals, and I'll write it in fancy letters or pink letters. This is going to be 7 meters because the units were in meters. 7 meters. Yippee! And we can check our answer using AutoCAD if we did our triangle correctly in AutoCAD. So let me take a dimension, let me take an angular dimension on this triangle here. Should be about 707. And I'll bring this to the precision that I want. Scroll down to primary units to control the precision. Yep, 707. I only want one significant digit. It is indeed 7, so we're correct. Let me deselect all so that you can see the 7. Yay! 7.